Welcome back to another episode of Satisfactory, and on this episode we're going to talk a little bit about dealing with fluids in Satisfactory. In my last couple of episodes I had some struggles with trying to load balance conveyors and specifically also load balancing fluid and getting fluid flow direction to work properly when dealing with our big oil refinery. So on this episode, I'm going to focus on what I did to get around those limitations and how I was able to improve my overall fluid flow. So sit back, relax, and let's jump into it. All right, we're here with this oil node that was kind of tucked off into the hill above our aluminum plant here, the one that we discovered in our last coal episode there. And I've thrown a fracker down here, and I've got oil extractors set up on these, and I've got all the oil coming out here. So we have two lines of 600 cubic meters per minute, and then one that's 150 cubic meters per minute that we're going to be playing with here for dealing with some, we're going to call it fluid dynamics here in Satisfactory. And when I was putting together my other oil refinery, and let's just quickly fly over there so we can show you what I'm talking about. So when I first designed the layout for this oil refinery here, I just had it in my head, you know, a manifold, or I'm dealing with a manifold of fluid that's going into these refineries, 600 cubic meters per line, blah, blah, blah. Well, the manifold for fluid is not necessarily the same because of fluid slosh. And there's some things that you can do to prevent that fluid slosh. Now, if I was to totally, knowing what I know now, this would be completely designed differently. I wouldn't have this laid out the way I do. But that's why we're going to go focus on, you know, how I combated, because the layout on this is absolute garbage. When you start looking at all the pipes and everything that I have all going, taking the heavy oil residue and trying to get them into our refineries making fuel and stuff, it ends up just being a spaghetti mess, and it doesn't look very clean. So I want to focus now on what an oil refinery plant would look like if you designed your fluid manifolds correctly to minimize the amount of fluid slosh that happens, which ends up massively cutting down the amount of refineries that end up turning off because they're slightly starved. Like this one here, slightly starved for oil right now, but it's not as bad as when I first turned this on in that episode. I had like the last four of every line, 4 or 5 of them weren't running, and then I'd have backup of excess resources going out, and it was a wreck. Well, it's working a billion times better now, but it just doesn't look very nice. So we're going to focus now on trying to make that look nice over on the oil node that we have the fracker running on over by our aluminum plant. So let's start looking at some designs for that oil refinery. All right, so the first little pointer that I want to give you here is gathering fluid is way easier than distributing fluid. Gathering up these, as long as you don't go over the 600 cubic meters of fluid that you're capable of dealing with, you have no problem whatsoever. They can just be tied together in a series, and eventually that pipe will fill up to 600 cubic meters. So for instance, I have this 300 line coming along here. It tees into this line. This is providing 300. I know I have 600 going out of this. Same on this line here. We have a line of 150 coming here and a line of 150 here. That's coming together. It's now 300 by the time you get to this point. It's combining with this 300 line. That's giving us 600. Boom, we've got 600 cubic meters of oil in that line. No worries. And finally, the last line is just a single line of 150 cubic meters of fluid that's going through there. Distribution is handled a little bit differently. And so I'm going to do a quick little mock-up here of how it's easiest to distribute this fluid. All right, we're going to work with this line here that is 600 cubic meters of fluid. And we're bringing this down And we're going to be right around the center of this workspace that we're at here. I'm going to say center is roughly right about here. And we're going to turn this 90 degrees so that we're working in this space here. So say we've got 5 different pieces of equipment that or 6 pieces of equipment that we want to connect to that are going to use this at 100%. So that's going to be 100 cubic meters of fluid that's going to get divided into those equally. So the first thing I'd like to do is with distributing fluid is I like to have my fluid. We're going to go with, let's grab this little piece right here. You want to bring your fluid in from both ends of the line that you're going to be distributing it with. So for instance, we're just going to use this as an example here. And we're going to take some pipe here. And we're going to run this down. And I know I'm going over like great distances here. It's fine. That's probably going to cap out there again. I did a lousy job of placing that one. Let's place that one at a better location than that. Let's make that a little better here. Grab our pipe, bring it down, make it nice and flat. So that's not crazy ugly. We'll do that one there. This here, and then we will connect it here. So the idea here is we're going to bring this line in and we're going to tee into it right here. And we're going to pretend this is the middle. This isn't the exact middle. This is close enough. We'll do that a little bit better so that I can line it up with this seam that's in the concrete here. There we go. We're going to pretend that this is the exact center of this line that's right here. And we're bringing this fluid in. It's hitting that. The idea behind this is in this manifold of fluid that we've got going here, it's going to hit this. And it's going to equally distribute the fluid that way and that way for our equipment that's going to be using this. Okay, so now let's take this line and we're going to bring this back this way. And we'll just put our little junctions in at the exact same spots that we had them in here before. So now we have this big fluid loop that's happening here. So we're going to distribute out now on this side. We're going to take 3 lines are going to go out this side. And 3 lines are going to go out this side. Now, I know this is not evenly matched, but this is just for a visual representation. And then we're going to go, this is off to whatever piece of equipment it's going to be. This is off to whatever piece of equipment it's going to be. And this is off to so on and so forth, all the way down this line. This is going to help with your fluid distribution, because what ends up happening is if you were to just bring this into one end here, it seems like all of the fluid ends up getting consumed, and you find that the last 2 devices here constantly end up getting starved out. And that's going to be because the fluid in this is sloshing back and forth with this pipe. And then the other thing that I do to combat this slosh that's happening is right when we start actually distributing it, grab a valve, throw a valve in here, and do the exact same thing at the other end. Throw a valve in here. These valves will prevent backflow. So it cuts out all the rest of this pipe being a factor in your fluid slosh. So now you've got basically 300 cubic meters of fluid that's going in this way, 300 cubic meters that's coming in this way. It's dividing it nicely. I know it's not really like this pipe, if it's not running, is going to fill up to 600 cubic meters, but it's just now it's pulling from that fluid from both sides, because these 3 pieces of equipment that are going to be connected at this end, they're pulling from this side first. And then if there's anything else remainder, they'll go to this side. Same with these 3 pieces of equipment that are at this end. They're going to pull from this side first because it's a path of least resistance. This is the closest fluid input. And then if it needs to, it'll pull from this side. But it's never really going to need to pull from here, because all of its available fluids from here. See, what would have happened before is if you just brought this line in and just teed it in here, you didn't have this kind of first split that's happened. Let's call it a load balanced manifold. We could call it a load balanced manifold for your fluid distribution. It's not really, but for ease of explanation, it does help picture how that fluid's going to flow. So with these little check valves in here, we've now eliminated any slop that's happening. This fluid can only flow this way. It's not going to go back this way at all, which helps eliminate some of that slop back and forth that's going to happen. Same at this end. This fluid is coming this way. Once it goes through that valve, it can't go back again. So we're not dealing with any more slop going back and forth. It's basically forcing that fluid to keep moving in this direction. Now, if you really wanted to be crazy about this, you could go through and put valves in on this as well too. But in most cases, where you're connecting to your pipe is going to be relatively close to the equipment that you're going to be using. So you're not really going to have a room for a valve at each individual piece of equipment. But as soon as I did this design out at my oil refinery over there for how it was dealing with the fluid output, all of my issues were completely resolved. I didn't have any more massive starving hiccups of some of my refineries just not getting the fluid as it was going through. There's another tip, and I'm going to put down a wall here. Sorry, not a wall. We're going to use this as a there's going to be just another foundation that's going to go along here. As tempted as you are, say you're going to build your equipment up on this level of this foundation. You want everything above the pipes because you want to be able to eventually cover up all these pipes. And your first inclination is to go, I'm going to grab a hole or a floor hole here. Where is it? There we are. I'm going to put this here, and I'm going to put this here, so on and so forth, so that when we start feeding these pipes through and up here, just to make it all look nice and clean and everything's all connecting properly and you get nice right angles, as tempted as you are to do this and then eventually out to your equipment, so on and so forth along the way here. You've used these nice floor holes and everything's looking like totally sharp and you're super impressed with how it looks. Save yourself the headache. Don't use the floor holes. I would say 30% of the floor holes that I laid out in my factory out there, for whatever silly reason, the fluid wouldn't go past it. And when you're trying to troubleshoot fluid flowing issues and why things aren't working the way they should, and it's something as simple as a floor hole is preventing it from flowing properly, you visually can't see it. You know, you're wondering, why is this thing? You're looking at the piece of equipment that's attached to it, whether it's a refinery or what that's attached to this, and you're going, why is it not getting any oil? And you're looking back here, and there's oil here, and there's oil here. It should be working. And then you click on this, and there's no oil in the line. I mean, there is on this example. This didn't work out right now, but you know, in some cases, these floor holes for the pipe just don't work. They don't connect properly. And then when you actually come along with your F to remove them, and you start to like click on some of the pipes and stuff that are here, all of a sudden you'll notice, wait, why does that pipe not go through? Like things weren't connecting properly when you go to click on it. And that was a huge struggle for my last power plant. So what do you do to get around that is this would be the only like acceptable clipping that you could go through, is bring it up so that you know you're at your 90 degree up, your 90 degree out, and use that as an acceptable clipping for this. And your life was going to be so much easier, because now it's just a continuous piece of pipe. There isn't a joint here where something could go wrong with the fluid transporting beyond them. And you're going to be so much happier with how you're going to deal with that. So what I'm going to do right now is I'm going to take these oil lines here and I'm going to apply these new theories, and you can see what it's going to look like with new oil refineries set up here, running this. I'm going to convert all of this into heavy oil residue and then into fuel, and make some new power plants out here. Not that I need the power after building a 117 gigawatt coal power plant. I don't necessarily need this, but I'm using this as an example for showing how to deal with these fluids. So let me show you what the finished product of the design would be using this manifold layout. All right, let's have a look at how we have our oil distributed. So we brought the oil line down. It comes down, feeds into our balanced manifold that we've got here. It splits off that way. It's feeding refineries from this end. It's coming around this way. It feeds refineries from this end. We do have our flow control valves at each end to keep the fluid going into the refineries. And then there's the service tubes that go up. Now we have the same piping coming down here. It's does the exact same thing on this set of refineries. And then we have our 150 line that's coming down, and it's feeding the 3 refineries at the end here. So I've just turned this system on, so we've got a little backlog of some fuel right now while our fuel generators fire up and stuff. But now everything is all balanced out, and it will work as needed to be able to run our fuel generators. The fuel generators, I have it distributed the exact same way under here. So we've got this line here. Basically with the fuel, the amount of fuel that we're producing is there's a full line of 600 cubic meters of fuel that's getting produced off of 3 banks of these refineries that are here. And then there's another 300 that's getting done off of this one bank and the last 3 refineries that are here, of which one of these is underclocked to 50% so that it balances out that this is consuming 150 cubic meters, which is what's coming off of that one node that's over there. So we have our manifolds here, our load balanced manifold that's feeding it from both ends, and we're doing the same thing on this, and that is keeping all of our generators running at 100%. So this is all designed so that these generators would run perfectly fine, except for this one is overclocked and it shouldn't be. Let's pull those out of there. I don't remember putting those into that one, but it's not supposed to be overclocked. Everything here should be. Oh wait, I did calculate this as overclocked. I do actually have to go through and overclock each one of these, which is why not all of this is running, is because we're not consuming enough fuel. So I got to get these all overclocked, because I need these consuming 30 cubic meters of fuel. So let me get this done, and then we'll see how things are running. All right, I just finished loading in the rest of those power shards. Now all of these are running at 300%. So we're getting all of our 250%, I think, of what it is. Yeah, 250%. That's 30 cubic meters of fluid fuel that's going into them, producing 375 megawatts, and everything now is running as intended. And now that we've fired that all up and it's running smoothly, a lot more of these refineries are starting to click in because things are getting consumed a little bit faster. So, but all in all, the whole purpose of this was to just kind of show you some tips and tricks on being able to deal with pipe. I didn't talk about head lift with these pipes at all, because I mean, we're all running off the same plane right now. Our highest point is our pumping solution that's up here. So head lift is kind of a whole nother ball of wax that you have to deal with, because pipes will only push fluid so far up. But if you can get your fluid source from a high location, then you never have to worry about it, because your head lift is always going to be as high as your highest point. So we could have built this factory way down at the bottom here, and we'd never have to put any pumps in or anything like that to to deal with head lift. But we built this all on the same plane here so that we don't have to worry about head lift at all. This was more, the purpose of this video was more just to talk about controlling the flow of your fluids going into your various pieces of equipment. Once you can get that done, it makes it so much easier to build your plants and plan your plants, because you have a better idea of how to maintain your fluid control. So with that said, guys, I hope you enjoyed this video. I hope you found some useful information in this. Reach down, hit the like button on this video if you could. Leave a comment. Let me know what you thought of this little tutorial, just to kind of give you an idea of, you know, what I found while working with fluid to be able to make things run more efficiently. So yeah, subscribe if you are new to the channel. That would be fantastic. And ring that notification bell so you can be notified when I have put up a new video. And you can follow me on Instagram and Twitter. With that all said, you guys have a good one, and we'll see you in the next episode.